4.3.6, maximum sustainable yield. Maximum sustainable yield, MSY, is the largest yield or harvest, you can think of a yield as a harvest, that can be taken from the stock of a species over an indefinite period. MSY should be used to set caps on fishing quotas. Typically, harvesting at MSY levels requires much lower fishing rates than occurs in many fisheries. Sustainable yield, SY, is calculated as the rate of increase in natural capital or natural income that can be exploited without depleting the original stock or its potential for replenishment. Exploitation must decrease long-term productivity. The annual sustainable yield for a given crop may be estimated as the annual gain in biomass or energy through growth and recruitment in migration of species. Okay. MSY aims to maintain the population size at the point of maximum growth rate by harvesting the number of individuals that would normally be added to the population, allowing the population to continue to be productive indefinitely. Okay, so this is important for sustainable fishing. If you want to have the population not crash, you have to know how much can we fish before it will crash. And well, you can fish the amount that equals the amount that's the population would otherwise be growing by. MSY is a measurement of the point at which the highest rate of capture fisheries can occur. This is often difficult to determine. It is used extensively by fisheries management. Populations of cod have been particularly affected by overfishing in the North Atlantic, as discussed previously in that example. Most of the stocks of the top 10 species, accounting for about 30% of world marine capture fisheries production, are fully exploited and therefore have no potential for increase in production. Okay, so you can't fish any more than we're already fishing. They're at their maximum. They're probably over it. The stocks of anchoveta in the southeast Pacific, Alaska, pollock in the North Pacific, and blue whiting in the Atlantic are fully exploited. Among the 7 principal tuna species, 1/3 are estimated to be overexploited. So overexploited means their populations are decreasing and probably risking collapse, whereas fully exploited means we're taking as much as can be taken without collapse happening. Developments in fishing equipment and changes to fishing methods, coupled with overcapacity in fleets and inadequate management, lead to dwindling fish stocks and damage to habitats. Okay, 4.3.7, climate change and ocean acidification. This was addressed a bit in section 4.2, right? Climate change and ocean acidification are having impacts on ecosystems and may cause the collapse of some populations in freshwater or marine ecosystems. Oceans naturally absorb carbon dioxide, but since about 1850, they have absorbed around 33% of the carbon that humans have released into the atmosphere. This has increased ocean acidification by about 30%. If CO2 emissions continue at the current rate, ocean surface pH could change from 8.1 down to 7.7 over the next century. Between 1955 and 2015, atmospheric carbon dioxide increased steadily from about 315 ppmv to about 400 ppmv. You can see that in this figure here. All right, figure 4.57. So along the x-axis, you have time going from 1955 to 2015, right? And on the left y-axis, you have carbon dioxide. And then on the right axis, you have pH. Okay. And then the key shows that the red line is atmospheric carbon dioxide. So that's being plotted year against the carbon dioxide y-axis. And the other ones, seawater carbon dioxide, okay, that's also against carbon dioxide. And then the seawater pH, that uses the other y-axis. You see how that works? So the light purple is the x-axis versus the pH y-axis, and the red line and the dark blue is the x-axis and the carbon dioxide y-axis. Let's see, where were we in the main text? Right. The carbon dioxide content of oceans increased from about 325 micro ATM in 1990 to about 375 micro ATM in the 2010s. In contrast, the pH of seawater fell from about 8.13 to about 8.05 between 1990 and 2013. So that is a summary of that graph, the trends of the graph. Increasing carbon dioxide levels, mainly caused by the burning of fossil fuels, right, are driving ocean acidification. Ocean acidification makes it harder for some species to survive and affects ecosystems, food chains, food supply, the economy, tourism, and recreation. The best way to prevent further ocean acidification is to reduce carbon dioxide emissions. Seagrasses may grow more quickly if more dissolved carbon dioxide is available, but oyster numbers may be reduced because fewer larvae, baby oysters, complete their life cycle due to the acidic conditions. Any life in the oceans is food for another species, and change in the abundance or amount of one species will have an impact on the others. Humans are affected too, due to relying on the ocean for food and other resources. For example, some 500 million people depend on coral reefs for food, for coastal production, and for their income. Some reefs, such as Australia's Great Barrier Reef, are increasingly vulnerable to bleaching events caused by rising sea temperatures. In turn, acidification may make it harder for coral reefs to recover from bleaching. Coral bleaching refers to the way in which coral reefs may turn white when they are stressed by changes in temperature, for example, light or nutrients. They expel the symbiotic algae living in their tissues, causing the coral to turn completely white. In Puget Sound, Washington, USA, the Suquamish people's economy and culture is related closely to shellfish and salmon. Ocean acidification reduces the number of shellfish and sea butterflies that are a key part of the diet of wild salmon. This is threatening the traditional way of life of the Suquamish. Ocean acidification affects food chains. Populations of species that feed on calcifying organisms, such as baleen whales, may decrease. In turn, this can affect the populations of species that feed on baleen whales, such as killer whales. Marine life at risk includes oysters, mussels, and squid. These species make up a high proportion of the seafood industry. In the USA, oysters, clams, and scallops provide seafood valued at US $400 million, so $400 million US dollars per year. In some coastal shorelines, acidification may also be caused by runoff from acidic soils and bedrock, such as gravels. 4.3.8, mitigating unsustainable exploitation. So mitigating, how do we stop it from getting out of control? Okay. Unsustainable exploitation of fresh water and marine ecosystems can be mitigated through policy, legislation, laws, that addresses the fishing industry and changes in consumer behavior. So, the buyer's choice. Actions occur at international, national, local, and individual level, including instructions on permits, quotas, like a limit on how much you're allowed to fish, seasons, when during the year you can fish, mesh size, like how big the holes are in the nets, so that it captures the fish that you want to capture and not everything. Zones, where you're allowed to fish, and food labeling, okay, marking what is in, so people know what they're eating and how it's been caught. Many scientists argue that measures such as quotas, bans, and the closing of fishing areas still fail to address the real problems of the fishing industry. What are the real problems? Put simply, too many anglers are chasing too few fish, and too many juvenile fish are being caught. Juvenile means young fish. Okay? So too many people are trying to catch too few fish. And we're catching too many young ones. For the fisheries to be protected and for the industry to be competitive on a world scale, the number of boats and the number of people employed in fishing must be reduced. So there can't be so many fishers. At the same time, the efficiencies that come from improved technology must be embraced. A World Bank and FAO report in 2008 showed that up to 50 billion US dollars per year is lost in poor management, inefficiency, and overfishing in world fisheries. The report puts the total loss over the last 30 years at 2.2 trillion US dollars per year. The industry's fishing capacity continues to increase. The number of vessels, which is boats, is increasing slowly. However, each boat has greater capacity, so more, they can hold more due to improved technology. Due to overcapacity, much of the investment in new technology is wasted. The number of fish caught at sea has barely changed over the last decade. Fish stocks are depleted, so the effort to catch the ones remaining is higher than it needs to be. Okay, so the fish aren't as available because there aren't as many of them. So we can't catch more. We can't catch more than what there is. So that's why it stayed the same. Changing consumer behavior. Consumer behavior is changing in some societies. Awareness of bio rights and the problem of overfishing has led some people to demand that the fish that they consume are taken from sustainable sources. So we're talking about that labeling aspect, putting the information on the product. The Marine Stewardship Council identifies and labels sustainable fisheries. Its website claims that by choosing MSC labeled seafood, you reward fisheries that are committed to sustainable fishing practices. MSC labeled seafood is available in 149 countries around the world, and the certified fisheries represent 10% of global wild capture seafood. Researchers have identified nearly 1,000 improvements made by MSC certified fisheries, improving the sustainability of the fisheries to global best practice levels of environmental performance. So things are getting better, at least in that respect. There are some people trying to make a difference. The Aquaculture Stewardship Council, ASC, sets standards for responsible aquaculture, i.e. farmed fish and seafood. Okay, standards means like rules that you should follow to be sustainable. A number of publications and films have promoted sustainable fishing practices or highlighted unsustainable ones. These aim to further change consumer behavior and to put pressure on governments and the fishing industry to stop unsustainable fishing. Changing the fishing industry. Okay, now this is we're going to look at table 4.12, possible strategies to manage the fishing industry in Europe. So there's lots of different things. It's worth opening the book and really reading through that table. Table 4.12 or 4.12 suggests some possible strategies to manage the fishing industry for the future, but there are clearly no simple solutions to the problems associated with such a politically, economically, and environmentally sensitive industry. Okay, so in this table you've got like actions and then what they apply to and what the point of it is. Okay, so for example, I'll mention some of them. Technical measures. Okay, so that's a type of action. The type of measure is small meshed nets, minimum landing sizes and boxes. which protect juveniles and encourage breeding, discourage marketing of illegal catches. Okay, so that's the point of it. So this with this net size, that was mentioned in the text, like bigger holes means that you capture the big fish and the young ones are small enough to not get captured, or things that you don't want, smaller things that you don't want. But in this case, what you don't want is the juveniles because you want them to reach maturity and be able to reproduce. Okay. Restrict catches. So saying like which is like you can make a quota or say there's only a certain amount that you're allowed to fish. And the point is to match supply to demand so that we don't have oversupply. And to plan quota uptake throughout the season and to protect sensitive stocks. You can read through some more of these. 4.3.9 Marine Protected Areas. Marine protected areas, MPAs, are areas of oceans, seas, estuaries, and some lakes in which some human activities are restricted to conserve the area and its resources. MPAs can be used to support aquatic food chains and maintain sustainable yields, sustainable harvests. Protected areas can benefit wider areas of sea. Okay, so even if you just protect a small area, it can have benefits for the rest of the sea. Okay, for example, by providing shelter or spawning grounds. Spawning is like, the laying of the eggs and the hatching of the eggs. Where those activities happen. If you protect just that little area, right, you're going to protect where once they hatch and grow and go out to the bigger, wider sea, you're going to have more of them, even if you just protect the spawning grounds. MPAs include areas of oceans, seas. Oh yeah, I said that part. Some lakes in which some human activities are restricted to conserve. Okay, MPAs vary in scale from large conservation areas off Antarctica and Greenland. So Antarctica and Greenland have really big conservation areas where activities are restricted, to small reserves around small islands. The International Union for the Conservation of Nature, IUCN, describes protected regions as distinct geographical areas that are acknowledged, like everybody is aware and agrees about it, and maintained either through legal provisions or other reliable methods to ensure the enduring preservation of natural environments along with the ecosystem services and cultural significance they provide. Okay? So there are specific little regions that you can protect. There are many types of MPA. Remember what MPA is? Marine Protected Area. There are many types. Completely marine MPAs with no significant land masses, so just an area of water or water and ice, kind of have ice on it. Okay. Or MPAs can include both marine and terrestrial areas, for example, an island and the water around the island. MPAs that are mainly terrestrial or tidal, like a beach, or like a mangrove swamp. There are many pressures on MPAs, including global climate change, ocean acidification, marine pollution, and extractive industries, including fishing and oil, gas exploration and development. In many cases, MPAs will try to restrict unsustainable development. For MPAs that are located entirely within one country's territorial waters, it is easier to enforce environmental legislation. Over 40% of Australia's MPAs are in its territorial waters. Some activities, notably fishing, may be restricted seasonally to protect spawning grounds. You can't fish here when the fish are laying their eggs. Some MPAs are multiple use and may have different levels of protection, such as a central preservation area surrounded by a buffer zone with maybe less protection. Like you can fish there. It's not like an area where you can't fish ever at all, and then like a buffer zone where okay, you can fish here sometimes of the year or to a certain extent. Okay, and then there's a good example here. The Queensland coast, Australia. One of the main attractions for tourists in Australia is the Great Barrier Reef because it's amazing. The reef extends for over 2,000 kilometers and covers an area of 343,800 square kilometers. It consists of over 2,900 reefs and is the world's largest living structure. It is also the most used marine park in the world. The Great Barrier Reef contains 1,500 species of fish, 400 species of coral, and 4,000 species of mollusk. It is a major feeding ground for many endangered species, and it is a nesting ground for many species of turtle. That's where they lay their eggs. It was placed on the World Heritage List in 1981. The reef is heavily managed. It's controlled. But before it was managed, it was used for tourism, agriculture, and recreational and commercial fishing. Each year, 77,000 tons of nitrogen, 11,000 tons of phosphorus, and 15 million tons of sediment are washed into the coastal waters from Queensland, largely as a result of agricultural activity. So farming, arable farming and pastoral farming, agriculture. That's a lot of nutrients, nitrogen and phosphorus being washed into there, and a lot of dirt. Because we talked about erosion, we talked about urbanization and farming and how it contributes to erosion. Erosion as well, the dirt goes down into the channels and gets washed out to the sea, and in this case, hits the barrier reef. The Great Barrier Reef Marine Park Authority is responsible for the management and development of the reef, it means basically taking care of it, and follows the Agenda 21 philosophy, namely that resources must be used and managed in such a way that they are not destroyed or devalued for future generations. The main type of management is that of land use zoning, so like making laws about what land can be used for what. This means that some areas can be used for activities such as recreation or fishing, whereas others are used for other activities such as conservation. The main aims of zoning are to ensure permanent conservation of the area, provide protection and shelter for selected species and ecosystems, provide spawning grounds, right? So where the eggs are being laid don't get disturbed, separate conflicting activities, preserve some untouched areas, and allow human use of the reef as well as protecting the reef. Okay, and there's this picture that I've had up here, which is the land use zoning along the Great Barrier Reef. Okay, so they have legislated, they've made laws that divide up this land like this into these different uses and say this is anybody can use it. This is general use. Here we've got habitat protection, so there's rules that go along with that. Here you're allowed to do research. You're not allowed to do research over here. That kind of stuff. Okay. 4.3.10 Aquaculture. The aquaculture industry is expanding to increase food supplies and support economic development, but there are associated environmental impacts to be considered, including the loss of habitat, pollution from feed, that means like fodder, like animal food, anti-fouling agents, that is like a spray or paint that you put on a boat that stops it from growing barnacles and algae. There's like chemicals in it. Antibiotics and other medicines used, spread of diseases and escapees that may be genetically modified. Management techniques can reduce the effect of negative impacts. Okay. So antibiotics there, like, I think it's going to go into the examples there. Yeah, this is just an introduction, and we'll get into it. Aquaculture involves raising fish commercially, usually for food. In contrast, a fish hatchery releases juvenile fish into the wild for recreational fishing or to supplement a species' natural numbers. Okay, so a fish hatchery is a place that hatches fish, that like makes new baby fish and releases them into the wild. Okay, whereas aquaculture is raising fish for food directly. The most important fish species raised by fish farms are salmon, carp, tilapia, catfish, and cod. Salmon makes up 85% of the total sale of Norwegian fish farming. Farming was introduced when populations of wild Atlantic salmon in the North Atlantic and Baltic seas crashed due to overfishing. Aquaculture is the farming of aquatic organisms, including fish, mollusks, crustaceans, and aquatic plants. It's a key definition. So there's a little box about between 2010 and 2019, the world food fish production of aquaculture grew by on average 5.5% per annum, which means per year. Some information there. Characteristics of aquaculture. Technological costs in aquaculture are high, including the use of drugs such as antibiotics to keep the fish healthy. Because when you have that many fish in that small of an area, they spread disease like crazy. So you basically have to bathe them in antibiotics. And steroids to improve their growth. That's gross. Breeding programs are also expensive, but efficiency and outputs per hectare and per farmer are high. So they do produce, these steroids and antibiotics, they work. Environmental effects can be damaging. Salmon are carnivores and are fed pellets made from other fish. It is possible that farmed salmon represent a net loss of protein in the global food supply because it takes 2 to 5 kilograms of wild fish to feed 1 kilogram of salmon. This is not efficient. In contrast, most global aquacultural production, about 85%, uses non-carnivorous fish species such as tilapia and catfish for domestic markets. Fish like herring, mackerel, sardines, and anchovy are used to produce the food, right, for farmed salmon. And so the production of salmon leads to the depletion of other fish species on a global scale. So we're catching anchovies and herring to feed them to the salmon that we're growing to eat. Other environmental costs include the sea lice and disease that spread from farmed salmon into wild stocks and pollution created by uneaten food, feces, and chemicals used to treat the lice, contaminating the surrounding waters. So aquaculture is kind of like, sometimes it's in the water, like in open, like kind of these permeable tanks on the coast. So like they dump the antibiotics and stuff just there, and then it just goes out into the surrounding water. But there's just the fish are caged. So they're kind of these open cages in the water. So not always like tanks on land, right? Organic debris of this type, along with the steroids and the other chemical waste, can contaminate coastal waters. Marine aquaculture requires energy for service vessels, fuel for your boats, while freshwater aquaculture uses electricity for feed and water circulation. Okay, so when you've got tanks, you've got to use electricity to feed them and to keep the water circulating so that they can breathe. The accidental escape of fish can affect local wild fish gene pools if they breed with individuals in the wild populations. This reduces genetic diversity and potentially introduces non-natural genetic variation. In some parts of the world, escapees of farmed fish threaten native wild fish because they are alien species. For example, the British Columbia salmon farming industry has inadvertently, not intentionally, by accident, introduced a non-native species, Atlantic salmon, into the Pacific Ocean. The positive environmental benefits of not removing fish from wild stocks, but instead breeding them in farms, are great. Wild populations are allowed to breed and maintain stocks, while the farmed variety provides food. Aquaculture produces a nutritious, healthy protein source, as well as vitamin D and omega-3 fatty acids. It can take place in a small area, unlike some large-scale farming systems. It also uses less water than conventional farming. Outputs per hectare and efficiency are also high. However, it destroys natural habitats and technology costs are high. For example, the cost of antibiotics, steroids, and drugs. Breeding programs can be expensive too. Aquaculture can lead to environmental damage, for example, the spread of disease from farmed fish to wild fish, or the escape of farmed, genetically modified fish, which can affect the local gene pool. It also takes a large amount of fish to produce the feed for farmed fish. Energy costs, for example, for farmed salmon can be high. Strategies used to minimize the negative impacts of aquaculture include moving the fish into deeper water, only locating the farms in areas that are well oxygenated so that you don't have to circulate the water, reducing the size of fish stocks and fish density so they don't spread disease so easily, and reducing food waste, being more careful about how you feed them so that there isn't a lot of waste going out into the water.